In the last class, I tried to establish the relationship between the three of them, and that's the relationship you can see on the board. So I am done with this, I am done with this, I am done with this. Now, there is something we call reactants. All these are X, used only in what? AC. We don't use all these terms in DC, and that's why AC is very important. Now, let us look at what is called reactants. Reactants. I have told you that the reason why AC is very important is because the three electronics serve one purpose, and that is the purpose of what? Regulation. Now, if two of these three are doing the work of regulation, meaning only the capacitor and only the inductor, only the what? Capacitor and only the inductor are doing the work of regulation, meaning in the circle there is no resistor. We only have capacitor and we only have inductor in the circle. Then that is what is called what? Reactance. So by definition we can say reactance is the regulation offered by capacitor or inductor or both to an alternating current circuit. I take it again. Reactance is the regulation offered by either the capacitor or inductor or offered by both of them, but resistor must not be there, offered to an AC circuit. So take the definition again. Reactance is the regulation offered by either the capacitor or the inductor or both to an AC circuit. For instance, these are circuits. These are circuits. In this circuit now, what I use as the regulation, as a regulator, is only what? Resistor. Here, I use only capacitor as a regulator. Here, I use only what? Inductor. This is symbol for inductor as what? Regulator. But if you look at this, I use the three of them. This is resistor, this is capacitor, this is inductor. I'm using the three of them as what? Regulator. So this type of circuit, we give what is called what? Impedance. But if either this or this is capacitor, either capacitor or inductor, either of them or both of them are found in the circuit, that is what is known as what? Reactance. So there is no way I would have drawn that. So in that I'll be having only capacitor and I'll be having only what? Inductor. So I can connect my circuit now. This is capacitor, this is inductor. So I can connect to our voltage, then I can connect to our AC. So look at this very well. Look at this very well. So you can see that what is regulating in this circuit is both what? Capacitor or inductor. Now if only capacitor is regulating, it is still called reactance. If only inductor is regulating, it is still called reactance. If both of them are regulating, it is still called reactance. So the definition says reactance is the regulation offered by either the capacitor or inductor or both in a circuit. Can't you see? Go on. Or you don't need to cut it. Either the capacitor or inductor or what? Or both. Now from that definition, we will understand that there must be time for what? Reactance. Because the definition said that regulation can be offered by what? Capacitor. Or offered by what? Inductor. So if the regulation is offered by the capacitor, it shall be called capacitive reactance. That's the name. If the regulation, like so in this case now, this circuit, we give a capacitive reactance because only a capacitor is used as a what? Regulator. Now if the regulator is offered by only the inductor, it shall be called inductive reactance. So if you look at this circuit very well, this circuit will give an example of inductive reactance because the regulator here is only what? The inductor. So how do we define the both now? Capacitive reactance is the regulation offered to an AC circuit by only the what? Capacitor. By only the what? Capacitor. So capacitive reactance has a formula that must be noted. According to the definition, take it again. Capacitive reactance is defined as the regulation offered to an AC circuit by only the what? Capacitor. So mathematically, this is capacitive reactance. This symbol for capacitor, and this is the symbol for reactance, is equals to 1 over 2 pi Fc. So this is pi, this is frequency, and this is what? This is capacitance. So for you to calculate for capacitive reactance, this is the formula you need. Now, the other type of reactance is inductive reactance. Inductive reactance. So this circuit will give an inductive reactance. Why? Only inductor is used as the only what? Regulator. Only inductor is only inductor is used as the only what? Regulator. So how do we now define inductive reactance? Inductive reactance is defined as the regulation offered to an AC circuit. Offered to an AC circuit by only the what? Inductor. Now mathematically I can have inductive reactance, N for inductance, X for reactance equals to 2 pi Fn. We continue from the next slide.